In real life, pipes made with different materials are used for different purposes. For example, copper is often used for domestic water supply, air conditioning, and fuel gas distribution. Stainless steel is used for water distribution, oil and chemical transportation. Cast iron pipe is often used for water and sewage systems. The applications of these materials are related to their strength, resistivity, and thermal diffusivity. Our experiment demonstrates how heat transfer changes between materials with different thermal diffusivities. In this experiment, we aim to find out how thermal diffusivity affects the rate of heat transported through different materials. To find out how thermal diffusivity, alpha, affects the rate of heat transport, we decided to use materials that we know have different conductivities, since thermal diffusivity is a function of conductivity, density, and heat capacity. We calculated thermal diffusivity for 3 materials and found that aluminum has a fairly high alpha value, stainless steel has a pretty low alpha value, and copper has an alpha value between that of aluminum and stainless steel. To test only thermal diffusivity, we chose pipes of these 3 materials with the same sized inner and outer diameters. We placed jawbreaker candies at the same distances from the heat source on each rod. The heat source, the hot plate, provides the same amount of heat to all 3 rods. By keeping these factors the same between all 3 rods, we can ensure that we are testing only for thermal diffusivity and how it affects the change in temperature over time. In order to demonstrate the effect of different thermal diffusivities, we glued 3 jawbreakers to the outside of rods of 3 different materials: aluminum, copper, and stainless steel. We placed the ends of all the rods on a hot plate that was heated up to about 410 degrees Celsius. Since the glue used to attach the jawbreakers to the rods melts at about 100 degrees Celsius, we knew that the first jawbreaker on the rod with the highest thermal diffusivity would reach 100 degrees the fastest, melting the glue and causing the jawbreaker to drop. As predicted, the first jawbreaker on the aluminum rod fell first, followed by the second one of the aluminum rod and the first one on the copper rod. Because of the difference in thermal diffusivity was so high between aluminum and steel, all 3 jawbreakers on the aluminum rod fell before the first one did on the stainless steel rod. All of the terms in the differential equation of heat transfer remain the same between each rod, except for thermal diffusivity and the difference in temperature over time. Since all 3 rods start at a room temperature and the melting temperature for the glue is constant, we can say that the change in temperature is also constant between the 3 rods. Simplifying the differential equation of heat transfer, we can see that thermal diffusivity is inversely proportional to the time it takes for a particular location on the rod to undergo the temperature change needed for the jawbreaker to fall. This explains the outcome of our experiment. Looking at just the first jawbreaker, the aluminum rod reached the glue's melting temperature first, then copper, then stainless steel. This is inversely proportional to each rod's thermal diffusivity. The effect of different materials having different conductivities is shown in real-life examples. For instance, CPU cooling systems use copper tubing and aluminum fins to dissipate heat. As shown in our experiment, both of these materials conduct heat very well and are able to effectively dissipate heat. Baking sheets are often made from aluminum. This way, the temperature of the baking sheet quickly obtains the desired temperature and spreads the heat evenly to cook the food. Refrigeration piping is usually made from copper. Again, this allows for good heat transfer between the working fluid and the surroundings, resulting in a more efficient refrigerator. Home insulation is typically made from fiberglass because its conductive properties are essentially opposite those of the materials we looked at in our experiment. For reference, the alpha value for fiberglass is about 2,000 times smaller than that of aluminum.